Hello dear students, I am Dr. Sharad Kumar, Assistant Professor, Department of Wildlife Sciences, Aligarh Muslim University, Aligarh. The information about the habitat of a species is crucial to plan the conservation strategies for long-term conservation of the species. In this lecture, I shall discuss the various plot and plotless techniques used to sample the habitat of various biodiversity values. What is habitat? We define habitat as the resources necessary to support a species over space and through time. Species depend on a number of environmental resources in a particular area for their long-term persistence, and these resources comprises a species habitat. Various resources play an important role in the quality of habitat, and any fluctuation in these resources can affect a species at both the individual and population level. Vegetation is an important resource of the habitat of a species and often used to study the habitat utilization by the species. Cover and density are two important characteristics of vegetation. Now, we learn various plot and plotless techniques used for vegetation sampling. Plot-based techniques. In plot-based methods or techniques, there is a boundary and sampling is done within the boundary. These methods involve counting of plants or determining the cover of plants or vegetation in a specific area. Quadrate method can be used for assessing biodiversity of any area and the cover of vegetation of any area. Vegetation generally comprises of tree, shrubs, herbs and grasses. For each layer, we take different size of plots, such as for tree 10 into 10 meter plot, for shrubs 5 into 5 meter plot, and for grasses half into half meter plot. Circular plot method. Select a point randomly in an area or a habitat, or select a point on a transect. Then, circular plot of usually 10 or occasionally of 20 meter radius is used for documenting and estimating trees, 3 meter for shrubs, and 1 meter for saplings and seedlings. Within the plot, count is made for number of individual of each tree species. Other parameters recorded at the sampling point are tree height, tree GVH, and other parameters. Then, density of the trees or the shrubs or the herbs or the grasses can be calculated by using the following formula. Density is equal to number of individuals divided by plot area, where plot area is pi r square, where r is the radius of the plot. This is the depiction of 5 meter circular plot used to count the shrubs to determine the shrub density and diversity in the habitat of a species where vegetation is sparse. We should use large circular plots in areas with sparse vegetation in comparison to the areas having dense vegetation. So we can use 20 meter circular plot for trees and 5 meter circular plot for shrubs in areas having sparse vegetation. such as the deserts. Frame quadrate method. Take a point randomly on the ground or take a point on the transect. Then place the quadrate on the ground or make the quadrate with the help of a rope and nails. A quadrate can be a rectangular or can be a square plot. Record the number of individuals of each plant species present in the quadrates and then calculate the density of the species by using the following formula. Density is equal to number of individuals divided by area of quadrate, where area is equal to side square in case of square, L into B in case of rectangle. Welt transect method. Normally, transect is a straight line placed in the sample area or area of interest. Welt transect is a rectangular area centered on this line laid by the researcher or the observer in the sample area. Use a compass to establish the center line of the transect and ideally at right angles to the edge of the road or the field or from the any path. Stand at your point of origin and mark it with a flag or with a color on some plant and sight on the most distant tree from the point of origin along your compass bearing. Then take a stick of 1 or 2 meter and count all the plants which are 1 or 2 meter from the line. The stick help in determining whether the plant is inside or outside the rectangular belt transect or rectangular plot. Density will be calculated by dividing the number of individual of a species by the total area of the plot. While the total area of the plot can be calculated by multiplying the length of the transect with the width of the plot. Daubenmeier frame method for cover estimation. The frame is made up of 3 by 8 inch iron rod with inside dimension of 20 into 50 centimeter. It also has 4 sharpened leg of 3 centimeter long to place the frame on the ground. 6 cover class frame is divided into fourths by painting alternate section of the frame by different color, generally with black and white or with black and red. One corner of the frame delineate two sides of an area of 71 millimeter square. So means it is 71 into 71 millimeter. This painted design, which is located at the right hand side of the frame, provides visual reference area equal to 5%, 25%, 50%, 75%, 95% and 100% of the plot area covered by the vegetation or by the different items on the ground. This is the field illustration of the Daubenmeier methods to estimate the cover. Plot arranged within the painted frame that designated area percentage. Each crossbar is removable for easy placement of the frame on the ground. After placing the frame on the ground, percent ground area covered by different items or vegetation is calculated with the help of this frame. Some viable plans to deal with plants on boundary. While doing vegetation sampling, sometimes there are plants which are located at the boundary of plots. Then the researcher or the observer are in a dilemma whether to include these plants in the plot or not include in the plot. We need to take decision whether to include these plants or exclude these plants. We can use following any of the following plants to take the decision on the plants located at the boundary of the plots. Plants are considered in if any part of the plant boundary is touching the plot boundary along two adjacent sides of a rectangular plot, and consider out if any portion of the plant boundary is touching the other two sides of the plants are counted as in or out. Alternatively, number 2, plants are counted as in or out alternately along the boundary. Plants are considered in if more than 50% of the plant boundary is within the plot. Plotless techniques or distance-based techniques. These techniques are also known as distance methods and estimate plant density by measuring the distance between plants or between plants and some random points. In these techniques, density estimation is done without the help of a quadrant or a plot, means these techniques are boundaryless. These techniques are advantageous for researcher or the surveyors when there is a shortage of time, area is large and manpower is less, as these techniques are faster and easier to implement in the field. Counting the number of plants in plot can be very time consuming. Therefore, alternative methods have been developed that are based on the distance between the plant or the distance between a specific point and a plant. One unavoidable truth when measuring vegetation density is that plant density and distance between plant is inextricably linked. High density means plants that are close together and distance between them is less, or low plant density means plants that are far apart from each other and distance between them is more. Distance measures methods or distance methods or the plotless methods are based on the concept of a mean area per plant or the main area covered by the per plant. These methods are most often used for large or scattered individuals such as trees, for which the use of quadrant is not practical and feasible, or for habitats where making quadrant is difficult. Now we will learn about some widely used plotless technique for the vegetation sampling. Nearest neighbor method. This is the depiction of nearest neighbor method, where distance of a nearest neighbor of a selected tree is used to calculate the density of trees. In the technique, distance from a selected plant to its nearest plant or neighboring plant is measured. After reaching at the sampling point, first choose a referent plant, usually the closest individual to a selected point is taken as the reference plant. Identify the plant closest to the reference plant and measure the distance between these two plants. The density of plant is estimated by using the equation A upon 1.6 into D का whole square, where A is equal to specified area, for example in meter square or hectare. D is equal to distance measured from target plant to the nearest plant. 1.67 is a multiplier determined through field experiment that allow for accurate estimate of area covered by a plant. Point-centered quarter. This is the depiction of point-centered quarter, and it is based on measuring the distance of nearest tree in each of the 4 quarters created at the sampling point. In this method, distance from a sample point to the nearest plant in each of the 4 quarters or quadrant is used to determine the density of a plant in a particular area. First, choose a series of points in the sample area, at least 15 points in the study area, by following any sampling strategy. Points can be taken on the transit line or randomly after 200 paces or 400 paces or 500 paces. After reaching at a sampling point, place a cross or plus shaped guide or frame over the sampling point to create 4 quarters or quadrant at each sampling point. Then, measure the distance from the point to the nearest plant of interest in each of the quadrants. These distances are used to determine the density of plants by using the following equation. Density is equal to A upon D square, where A is the specified area, for example in meter square or 1 hectare. D is the average of 4 distances measured from center point to nearest plant in each quarter. Closest individual method. This is the depiction of closest individual method, and here distance of closest individual from the sampling point is used to determine the density of plants. In this technique, distance from a sampling point to the closest individual or plant is measured. First, choose a series of sampling points in the sample area by using any sampling strategy. After reaching at sampling point, measure the distance to the closest plant of interest from the sampling point. The density will be calculated by using the following equation. A divided by 2D का whole square. A is equal to specified area, for example in 1 meter square or 1 hectare. D is equal to distance measured from point to nearest plant in any direction. Units of A and D must be same. If A is selected as meter square, then D should be expressed in meters for all the methods. Random pair method. It is the depiction of random pair method, and it is using the distance between the random pair of plants in the study area to calculate the density of the plants. A random starting point is chosen as the first sampling point along a transit. From this point, a tree nearest to that point is selected, and surveyor or the researcher remains standing on this first sampling point and turns towards the selected tree. The surveyor spread out both arms to form an 180-degree exclusion angle perpendicular to the direction of the first sample tree. A second person then measure the distance from the first sample or reference tree to a second tree that is closest behind the line formed by the 180-degree exclusion angle. The density will be estimated or calculated by using the following equation. Density is equal to A upon 0.87 d ka whole square. A is equal to specified area, for example 1 meter square or 1 hectare. D is the distance measured between two plants. Point intercept method. It is used to determine the ground cover. Basically, a point is a very small plot that is measured to determine what plant or soil attribute occur at that point. To determine ground cover, assessment points are usually accomplished with a pin or a long metal wire that is sharpened to create a point. No matter how the point is created, at each point the species, vegetation type, for example grass, herbs or shrubs, or ground cover, for example rock, bare ground, biotic crust, etc., that intersect the point is recorded as a hit by the observer or surveyor. At each sampling point, surveyor can use either of crosshair sighting device or 10-point frame or crosshair point frame to create the hit in the field. After sampling, the cover by a particular type of item or a vegetation can be calculated by using following formula. Cover of a species or item is equal to number of hits of a species or item divided by the total number of hits and multiplied by 100. This method can be used to determine ground cover, basal cover, canopy cover and foliar cover. It is easier to determine if a point hit the base of a plant, for example basal cover, or a leaf, for example foliar cover, than if a point is in the canopy of a plant. This method is seldom used to estimate canopy cover, though it is possible to estimate the canopy cover. Step point method. It is used to determine ground cover in the sample area. First, select a point to begin and then set a transect direction with the help of a compass bearing. After that, walk following the bearing of transect and record what occurs at regular interval along the transect. Regular intervals are created by counting a number of paces between hits, which are usually a pin that is set to the ground at a specific point on the surveyor's boot. Cover can be calculated by using following formula. Cover of a item, number of hits of a item divided by total number of hits multiplied by 100. Line intercept method. Laying down a transect and telling of how much of a plant intersect the transect is known as the line intercept method. Line intercept method is fairly objective method to determine the cover. In the method, along a line, when a plant touches the line, surveyor record what the plant species is and where the edge begins and ends. Beginning and end point for each time a plant intercepts the line can be recorded and the total distance of intercept can be calculated. If a sampling objective can be met without keeping track of the exact place where a plant intercepted the line, then all that need to be recorded is the distance of intercept along the line. In this method, lines should be as thin as possible. When reading distance along a transect created with a measuring tape, read only along one edge of the tape. It is also important to ensure that tape is not unintentionally moved to include or exclude certain plants. Usually, this method is used to estimate visual and canopy cover, but can be used for foliar cover for species that have large leaves and dense canopies. Cover of a species can be calculated by using following formula. Cover of a species is equal to total distance covered by a species divided by the total distance of line multiplied by 100. Thank you.